Okay, so for your warm-up, you were supposed to define circumference. Hopefully you remember from previously that the circumference of a circle is the distance around the circle. All right, and the other thing you wanted to think about was to find the length of weather stripping you would need to go around a window that was shaped like this. All right, so it's something that we don't know how to solve yet, but by the end of the class today, we'll know how to solve that. Also, the formula for circumference, there are two. You might remember it like this, 2 pi r, or pi times diameter, pi times d. All right, so let's look at what we're learning today, which is all about arc length. Arc length is just the length of a piece of the edge of a circle. All right, in the last unit we talked about the measure of an arc, and remember the measure of an arc was just the degrees. It was only related to the central angle. It didn't matter how large or how small the circle was. Whatever the angle of the central angle, the measure of the central angle was, that was equal to the measure of the arc. So arc length, when we talk about the length of an arc, we're talking about the part of the circumference, the actual distance between the end points of that arc. So if we could take a ruler and bend it around here, that's what we're talking about. So the arc length is a part of the circle's circumference. All right, so it's just the length of a piece of a circle. It's part of the circumference. So our formula for arc length, if we think about it as part of the circumference, the part is going to be our fraction, which is theta over 360, where theta is the central angle measure. All right, so that's our part. Of, when we're talking about words in math, of is one of those that usually means multiply. So part of the circumference, and the circumference formula we of course know is 2 pi r, where r is the radius of the circle. Okay, now because of the rules of multiplication for fractions, we know that if I put this over 1, I multiply the tops together and the bottoms together. Another way to write that arc length formula, and the way it appears on your formula sheet, is 2 pi r theta. So this all goes on the top, 2 pi r theta, and 360 times 1 is just 360. Okay, so this is the way you'll see it on your formula sheet, so that might be the way that you want to remember it. But it's the fraction multiplied by the circumference of the circle. All right, so if we wanted to find the length of the arc, if I wanted to find the length of arc AB right here, I'm going to use my formula. So 2 pi r theta over 360. Again, r is the radius of the circle, which in this case is 5, and theta is the measure of the central arc, of the central angle, which is the same as the arc, so 50 degrees. All right, so if I plug that into my formula, that's 2 times pi times 5 times 50 over 360. And guess what? You can just punch that straight into your calculator. So I'm going to pull up the calculator here if I can find it. Oh, wrong one. Well, if you pull it up on your calculator, you can just use the fraction button. So you hit your fraction button first, and then 2 pi 5 times 50 on top of the fraction, and then 360 on the bottom. And you get 25 pi over 18. Our units here were centimeters, so this would be centimeters. This is what we call the exact answer. So when it's in terms of pi, it is the exact answer. If we want it as a decimal, which is what it asks us to do, this is our rounded answer. So this is exact. To get the rounded answer, I'm going to punch that in the calculator again. I'll hit the double arrow. And so my approximate answer, and it said rounded to the hundredths place, so 2 places past, is 4.36 centimeters. Okay, so exact, and this is rounded. All right, so for part B, go ahead and try that. Take a second and try it on your paper. Set it up. All right, and when you set it up, the radius, of course, is 7, and the arc length, or the measure of the arc, the theta, is 50 degrees. Notice that the measure of the arc was the same, 50 degrees, theta was the same, but the radius is larger, so our arc length should be larger. Right, so we punch that in the calculator. And you should get 35 pi over 18, and again our units were centimeters. If I make that a decimal, that's about 6.108, so about 6.11 centimeters. All right, so notice that unlike the measure of the measure of arc AB is 50, the measure of arc CD is 50 because it's the center rule, angle equals arc, but because circle B is larger, has a radius of 7 instead of 5, the length of the arc is longer. Alright, so for this next one, we've got the spokes of a bicycle wheel form 10 congruent central angles. So that means all of these angles here are congruent. 10 congruent central angles. The diameter of the circle formed by the outer edge of the wheel is 18 inches. Alright, so if the diameter is 18 inches, what is the radius of the circle? So think about that for a second. We want to know to the nearest tenth, what is the length of the outer edge of the wheel? Alright, so if I want to find the whole length of the wheel, that's just the circumference of the circle. So we don't really have to have radius for that, but hopefully you figured out the radius should be 9. Again, the radius is half the diameter. So the whole length around the circle is just the circumference. 2 times pi times 9, or 18 pi. And if we want the decimal, which it said it wanted to the nearest tenth, we use our double arrow. So the circumference of the circle is 56.548. So that's about 56.5, and it was inches were our units. So 56.5 inches is the circumference of the tire, so all the way around. Now, a more interesting question is, what would be the length of the tire between two spokes? So what if I only wanted to know this length of tire? Well, that's arc length. I need to know the measure of this angle. Well, if that's 10 congruent angles, we know all the angles in a circle add up to, hopefully you know it's 360. And if there's 10 of them that are the same, each one of these is going to be 360 divided by 10. So 36 degrees for each of these central angles. So the arc is 360. So if I want to know just the length between one pair of spokes, I would use 2 times pi times the radius, which is 9, times theta, which is 36 degrees, over 360. And then we can just punch that in the calculator. So fraction button, 2 pi 9 times 36 over 360. And that gives me 9 pi over 5, or about 5.65, so about 5.7 inches. Now, you might have figured out that we could have taken this, since this is divided into 10 equal parts, we could have also done the circumference divided by 10, and it would give us approximately the same thing. It's going to be a little bit off because of rounding, but it would have given us the same thing. Alright, so take a couple seconds and try these. Pause the video, and then when you've had a few minutes, go ahead and start the video back. Alright, so for our arc length here for this first one, the arc we're trying to find is the bold one. So our arc length is going to be 2 times pi times 11 times our arc measure, which is 315 over 360. And then we can just punch that in the calculator. So 77 pi over 4, and the directions said to round to the nearest tenth. So our arc length would be 60.47. That would round to 60.5 feet. Alright, for the second one, we don't have a picture, but we know the radius and theta. All we have to do is plug it in. So 2 times pi times the radius times theta over 360. We punch that in the calculator. And that gives us 6 pi, and as a decimal, 18.849, so about 18.8. And our units were centimeters, so 18.8 centimeters. Alright, now notice the directions here say the exact answer, and it says use pi. So what that means is we don't have to get the decimal, we want to leave it in terms of pi. So our circle, our arc length again, 2 times pi times the radius, which is 8, times our arc measure, which is 15 degrees over 360. We'll punch that in the calculator. So 2 pi times 8 times 315 over 360 gives us 14 pi. That is the exact answer. Our units are centimeters, and that's all we have to do. We don't have to get the decimal. Alright, for this one, our arc length, 2 times pi times 19 times 150 over 360. We'll punch that in the calculator. So fraction button, 2 pi 19 times 150 over 360 is 95 pi over 6. Alright, and again, the directions said exact answer, so we leave it in terms of pi. Our units were feet. So our answer is just 95 pi over 6 feet. Alright, so the hands of a clock form the same angle at various times of day. The angle formed at 2 o'clock is congruent to the angle formed at 10 o'clock. If a clock has a diameter of 1 foot, what is the distance along the edge of the clock from the minute hand to the hour hand at 2 o'clock? So I'm going to sketch a picture of this. So we have a clock. We know that this is 1, 3, 6, 9. Alright, so at 2 o'clock, we know that the minute hand is here at 12, and the hour hand is over here. Let me redraw that at 2. And we want to know what this angle is so that we can find this distance between that. Alright, well, we need to know what the angle is. The easiest way to figure that out is to think about how many different angles are formed between 12 o'clock and each number. So if I look at 12 to 1, 12 to 2, 12 to 3, I can figure out that each quarter hour is divided into 3, or if I go all the way around the circle, that would be 12 of these equal angles. So we again know that all the way around the circle is 360 degrees. So each of these little angles here that are formed would be 360 divided by 12, because there are 12 different of those little angles. If I keep drawing those, you can see between this would be 3 to 4, 4 to 5, 5 to 6, and so on. So if I divide that out, 360 divided by 12 gives me 30 degrees. So each one of those angles is 30 degrees. Alright, so from 12 to 2, it's 30 degrees to 1 o'clock. It's then 30 more degrees to 2 o'clock, so that's 60 degrees total. So to find my arc length, again, I know I'm going to use 2 pi r theta over 360. I just found theta. Theta is going to be 60 degrees. I need the radius. So it says that the diameter of the clock is 1 foot. 1 foot is 12 inches. So that means 6 inches would be half of that. So r is 6. So 2 times pi times 6 times 60 degrees over 360 is going to be our arc length. So we punch that in the calculator, fraction button. 2 pi 6 times 60 over 360 gives me 2 pi. Alright, and it didn't say whether we wanted it as a decimal or what, so we can just leave it as 2 pi. If we wanted the decimal, we hit our double arrow, and that would be 6.28 inches. Alright, number 2, some irrigation systems spray water in a circular pattern. A nozzle is placed right at the corner of a house, but is set not to spray the house. Okay, so let's visualize this. So let's say that this is from a view from up above of a house, and it says that the sprinkler is set at the corner of the house, but we don't want it to spray the house. Alright, so that means it's going to spray all of this, but not this. Okay, so we need to know what this angle is going to be. The spray has a radius of 12 feet. We want to know the approximate length of the arc the spray creates. So if you can imagine, the little sprayer is going spray, 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 spray all the way around here, but not right here. So to figure out this arc, I need to think about what angle do I have here at the house. Alright, well, most houses are square or rectangle, so we're going to assume that it's a square or a rectangle house. So this is 90 degrees. So that means that the rest of this is going to be 360 minus 90. So that's going to be 270 degrees for this whole big arc here. Alright, I already have the radius. Now I've got my angle. All I have to do is plug it in. So the length of the arc, again, 2 pi r theta over 360 is going to be 2 times pi times 12 times 270 over 360. So we can punch that in the calculator, hit the fraction button. 2 pi 12 times 270 over 360 gives me 18 pi. Double arrow. That's about 56.548, so about 56.55 feet would be the length of the arc of that spray. Alrighty, true or false? Some things to think about. 2 arcs with the same measure have the same length. Alright, so if we think about that in terms of circles, if I think about a little bitty circle, let's say that we'll just do 90 degrees because that's easy. Is this arc going to be the same length as a bigger circle that has an arc of 60? Hopefully you can see that that is not true. So this is false. The larger the circle, the longer the length of the arc. Now the measures are the same. Those are both 90-degree measure arcs, but the lengths are going to be different. Next one, true or false? If the radius of a circle is doubled, the length of the diameter is quadrupled. Alright, well, let's think about that for a second. So let's say that we have a radius of 4. If I double that, that would give me a radius of 8. Alright, if I started out with 4, my diameter was 8. This new radius would give me a diameter of 16. So is the diameter quadrupled from what it would be here? So is 16 quadruple 8? And that is false. Okay, it's 4 times longer than the original radius, but not 4 times longer than the original diameter. Alright, and number 3, 2 arcs with the same length have the same measure. Okay, well, let's think about whether that would be true or not. If we knew that the radius was the same, that would certainly be true. But is it always going to be true? So let's think about a couple of circles. So let's say that this is 60 degrees. And let's say that this is 120 degrees. Would there ever be an instance when those arcs would be the same length, but the measures, obviously the measure right here is different. So this is 120 for a measure, this is 60 for a measure. So could it ever be true that those arcs would have the same length? And the answer to that is yes. The arcs could have the same length, because if we think about our formula, 2 times pi times r times theta over 360, the theta here would be different. Okay, so for one it would be 60, for the other one it would be 120. All I would have to do to make the arcs the same is to have this one have a radius that's twice as much. So if this radius is 8 and this radius is 4, then this arc length is going to be 2 times pi times 8 times 60 over 360. This arc length would be 2 times pi times 4 times 120 over 360. Alright, and if we look just at this part that changed, the 4 and the 120 and the 8 and the 60, if I just multiply that, I can see instantly that this is going to work out. 8 times 60, 6 times 8 is 48, so this would be 480. 4 times 120 is also 480. Everything else in the formula is the same. So I know that the arc length would work out to be the same. But notice again that the measures of the arcs are different. The measure here is 60, the measure here is 120. So two arcs that have the same length will not always have the same arc measure. So this is also false. Alright, so back to the warm-up. We wanted to know how much weather stripping we would need for this window. Well, we know that the weather stripping would only go where the blue is. So I know that this is 60, this is 36 on this side, this would be 60, and it tells us in the problem that this is half of a circle. So that means that I need half the circumference, or that's 180 degrees, for this length here. Alright, so to get that length, I have 180 for my theta. Let me write out the formula first. So 2 times pi times r times theta over 360. So that's going to be 2 times pi. Now the radius, if all the way across here is 36, then the radius would be 18, half of that. So 18. Theta is 180 because it's a semicircle. And then we can just punch that in the calculator. So I have 2, and my fraction button, 2 times pi times 18 times 180 over 360 gives me 18 pi, which as a decimal is about 56.5. Alright, now that's just for the curved part at the top. So all the way around the window, we have this 60 plus this 36 at the bottom, plus this 60 up the side, plus the curved part that we just found is 56.5. So the perimeter of one window is 60 plus 36 plus 60 plus 56.5, which is 212.5 inches. Now it says to round our answer to the nearest inch, and it says we want it to go around both windows, so we need 2 windows. So I'm just going to multiply that by 2. So 425 inches of weather stripping is how much we would need. Alright, so what you're going to work on next is your homework, which is in your homework packet. So go ahead and get started. You're going to be doing all of the problems on page 1. Happy arc lengthening!